we're not going to spend too much time graphing logarithms, but I do just want to do a couple, again, so that you're able to tell the difference between exponential growth, exponential decay, and logarithmic growth. I want you to be able to recognize the shapes of those graphs so that if you hear those phrases in other classes in chemistry or biology or anywhere else in the news, that you have an idea of what those phrases mean. Okay, so again, we're not worried about every little detail of the graphs of these functions, but I just want you to be able to hear one of those phrases and picture in your head the general idea of what that graph looks like and how it's behaving. Okay, so we'll look at a couple examples with logarithmic growth, and I think that'll be it. I think anything else we do graphing-wise is just going to be labeling what type of growth or decay a function is. So let's use our probably easiest log operation of log base 2. So y equals log base 2 of x. So we're going to plug in some values and see what they spit out, and we'll plot those points. We've got our graph of logarithmic growth. Now I picked the points 1, 2, 4, and 8. Those are going to be nice points for us. But notice that there's no negatives. I think it was in the end of the last video just before this that we talked about we can't plug in negatives for x here because log base 2 of a negative, there's no power that would get us to a negative. So we're not going to have anything on the left side of our y-axis. We can't even plug in 0 because there's no power that would get us 0. There's lots of powers that could get us close to 0, and we'll see what those are in a second. So we'll start with 1. Log base 2 of 1. So we're asking what exponent gets us to a 1, and that's 0. 2 to the 0 is 1. So log base 2 of 1 is 0. Log of any base of 1 should be 0. Okay. Log base 2 of 2. 2 to what power is 2? That's a 1. Log base 2 of 4, so that's why I picked these conveniently because these will come out even. So I picked the powers of 2. So log base 2 of 4, 2 to what power is 4? That's a 2. And 2 to what power gives us 8. So log is that's a 3, so log base 2 of 8 is 3. So we have the points 1, 0, 2, 1, 4, 2, and 8, 3. And so we see it curving up that way. And again, we can plug in values very close to 0, but we can't actually plug in 0. So this just decreases and goes right along our y-axis. So that kind of looks like exponential growth, but turned sideways. So here's the pattern of logarithmic growth. It starts out by increasing very, very quickly, and as it grows, its rate of increase slows down. So that's kind of the opposite of exponential growth, right? Where exponential growth started growing very slowly and speeds up. Logarithmic growth starts out by growing quickly and slows down. Okay? Logarithmic growth is maybe something like a population that's newly introduced into a new environment. So you put some bunnies in a new forest. It would grow very quickly, but then it would have to kind of start leveling off as it reached its carrying capacity, as the population got close to as many rabbits as could be supported in that environment. Okay, so logarithmic growth starts up by growing very slow or very quickly and slows down. Exponential growth grows very slowly at the start and then speeds up faster and faster, and then exponential decay. That's the one that kind of sticks out on its own because that's the only one that decreases. It decreases very quickly and then slows down. So those are the three types of growth that we're going to be comparing. I guess not three types of growth, only two of them are growth, one of them is decay. So now when you answer those, you can't just put growth because you'll need to distinguish between exponential growth and logarithmic growth. And just for fun, and since Natural log seems to be an important log. I wanted us to graph natural log of x, so it won't look too different than log base 2, because again, natural log is the log with base e, which is a 2.718, so it's not that different of a base than 2. But you're going to need your calculator to help get your table of values. So you're just going to plug in, we'll use the same values, 1, 2, 4, and 8. So in your calculator, plug in natural log of 1, natural log of 2, natural log of 4, natural log of 8. Take a second to do that. I'm going to pause recording, and so the values are going to pop up on the screen in just a moment right now. Ta-da! So hopefully you see the same values, and you're able to evaluate those in your calculator. You should be able to find the LN button and get those. So again, we'll just plot those quick. It looks very similar, but it looks like it grows a little bit slower. So we have 1, 0, 2, and then 0.69, so that's a little bit more than a half. 4, 1.38, 4, 1.3, so a little bit more than 1. And then 8, just above 2. So again, it grows out to the right, but slower and slower. We get right up on that y-axis, but never actually cross it. We can't plug in 0 or those negatives. So there's the graph of natural log of x. And again, the key skill I want you to have is to at least just be able to look at a graph like this and say, that's logarithmic growth. And if you can do that and tell that it's not exponential growth, then I'm happy. And you should be too.